afternoon, and welcome to Security in the Open, Incident Detection and Response for Open Source with Alistair Chapman. Alistair is a senior cloud security engineer at Red Hat, specializing in incident response and security architecture for public and hybrid cloud environments. Today, Alistair will present a broad rundown of all the new and exciting ways that things can go wrong in your security when working in the open. Please welcome Alistair.
Thank you, and welcome everyone to the Melbourne Convention Exhibition Centre and to the home stretch of Everything Open. We're getting to the end there. Before we get into today, I do want to acknowledge the traditional owners of this land, the Wurundjeri Woi-wurrung people of the Kulin Nation. Pay my respects to their elders past and present, and to elders of all First Nations communities that join us this week, and recognise this land's significance to those people for over 2,000 generations, and recognise that while these lands are for all of us to enjoy, sovereignty was never ceded. One more step before we dive in, and that's covering who I am. My name is Alistair Chapman. I'm a senior cloud security engineer based in Brisbane, Australia. I do work for Red Hat, but to be clear, this is all my view. So while a lot of what I'll be covering today has been guided by my experience at Red Hat, if you don't like it, complain at me, not my boss. You can find me basically everywhere as AGC93, and so I get to enjoy the wonders of open source security from both sides. I work in security for an open source company, and as outside of work, I tend to build a lot of open source software because I guess I hate myself. So we'll get into trust me, it's okay, this is the only bit of audience participation in the entire thing. I understand this is all a spectrum, but if I had to ask the audience to pick one of these three that you would identify with, can I get a show of hands who would be in the developer camp? Big chunk. Operations, non-code, anything like that? All right, and any fellow security? That's just as small a number as I expected. Okay, so with that out of the way, let's cover what I want to talk about today. As a few of you may have noticed, there's been quite a few excellent talks on open source and security already this week. So I'm going to be focusing a little less on areas like data privacy or vulnerability management, and a bit more on my area of expertise, which is incident detection, incident response, and the cloud. If you're looking for a lot more details, there's been a bunch of other presentations this week that you might find interesting. Particularly, I want to call out William Brown and Fraser Tweedale, both did excellent talks on specific technologies. And Alex Murray from Canonical did a really good talk yesterday on vulnerability management that for people building the code side of their projects might be particularly valuable. So we can go too far. So that's what we're going through today. The risks, what makes it different working in open source, what to watch for, which is detection, how to actually handle when something happens, response, and how you can control the risks in your project and learn from any incidents that you do have, which is protecting. So security for open source is not completely different to security for proprietary projects or corporate software, any of the traditional software markets. So there's plenty of useful information to be gained from security communities. That being said, the most common things that are really specific to open source, in my experience, boils down to probably three principles. There's a really blurry line between what's private and public, both from an information, from infrastructure, from code, all those sorts of things. You're having to constantly deal with contributions from untrusted third parties because the internet is a wild and dangerous place. And your tooling and infrastructure is much more likely to be available to everyone than you might be used to in, for example, a proprietary or more corporate-focused development environment that doesn't work with as much open source. But if we're going to talk about open source security, we need to look at the number one source of problems, the boogeyman in the night, the spectre around the corner, the demon that haunts the dreams of every InfoSec person who has to work with open source software, and that is the horror that is Git push. Because I cannot explain how many of the problems that you will find in open source projects comes down to someone Git pushing something they shouldn't have, or not Git pushing something they should have. Now, it is a bit reductive, so it'll come up a few times, but the explanation I'd like to give is that you need to treat Git push like you do sudo. To borrow the excellent lecture message, respect the privacy of others, think before you type, and with great power comes great responsibility. Because there is a lot of things you can do to your project with a simple Git push that probably don't seem so important at the time, but very much will be, often too late. So let's have a bit of a bird's eye view on incident response process. Now, I know flowcharts are kind of not really everyone's idea of a good time, and probably everyone's getting flashbacks to every bad corporate training session they've been sat through. But here is the overall bird's eye view of how incident response gets treated. These steps are roughly paraphrased from a guide from the US NIST document, 861, the Computer Security Incident Handling Guide. If you really want to learn more about incident handling and how security operations teams do incident response, it's an excellent resource. There's a lot of really good information in there. It's also an 80-page document published by a US government agency, so it's not exactly the most accessible of resources. But if you are interested, NIST 861 is very good. Most of you today probably don't need all the details, so we'll just look at this basic overview, which is that you start with preparation. That's where you're doing risk analysis, threat modeling, looking at your project, working out what you need to be worried about. You move into detection and analysis. That's how do you spot when something happens? What are you watching in your project to make sure that things are working the way they should? When something happens, how do you know it happened? When something does happen, you move into contain and recover. That is the, oh God, something's gone terribly, terribly wrong. How do I fix X, whether that's getting an attacker out of your project, fixing a vulnerability that's been introduced, trying to recover infrastructure that may have been impacted by an outage. There's lots of possible things, and those steps feed back into each other. So as you recover whatever incident has happened, you'll find more things, recover those, find more things. After everything's cleared up, you can move to post-incident activity, which is the simplified version, is that that's where you learn from all the absolute horrors that you've just had to walk through. The lessons from the post-incident activity will then feed back to your preparation so that you can ideally be better prepared and have better detection analysis in place to stop it from happening again. So that's the overall view. Today's going to jump around a bit, but we'll try and stick roughly to that sort of view of things. So for that first part, preparation and planning, how do you plan for the worst case scenario? Because it's very easy to think, oh, that's not going to apply to me, but sometimes it will. And the wonders of the internet in both the most positive and least positive ways means that there's not really any reliable predictor of whether your project or the team you work with is actually going to be affected by this. There's plenty of projects out there that have one maintainer and 6 users that are just as vulnerable to someone trying to inject malware into their package, or a massive organization with huge security operations teams that still get done because someone pushed their AWS key to GitHub. There's not really a clear division of what makes a project more or less at risk. Which means it's not just about, I should stop and point out too, it's not just about your code. That while everyone's immediate instinct is vulnerabilities in my code, there's a lot more to your average project as they gain complexity users. There's a lot of expectations from users around how projects operate. That means you've got things like documentation, demo sites, projects running hosted versions of their projects, whether that's for demonstration purposes or as actual services. There's a lot of infrastructure and tools surrounding a project that are just as important as the actual code. There's plenty of scenarios where you might be the greatest C# or Haskell or Java developer, but you'll still introduce problems because while you might be great at those, you're probably not quite so crash hot at Terraform. And there's a lot of open source maintainers let's go with hesitant to look at the full process of proper risk management. And that's for a good reason. Risk management is kind of hard and not something that a lot of developers are going to enjoy. You're going to sit down and go, I've got 2 hours to work on some stuff. I can bang out this really cool re-implementation of a feature I don't like from 2 weeks ago, or I can spend 2 hours reading PDFs about how to do accurate threat modeling of my project and assess my... No one's doing that. So there is a tendency to lean towards winging it. I'm going to say, from my point of view, bad idea, because it's much better to be over-prepared than under-prepared when it comes to security. So what should you be worried about? And honestly, that's the most important question you need to answer. If there's anything you take from today, you need to have an answer to that question, because the answer to that question will vary based on your project, your team, what your users do, how your software is implemented, what other services you have, all those sorts of things. It's very nice to be able to sit around and go, how am I going to be able to improve my project security posture? But the only way to answer that is to know what you need to improve. So as an example, if you're an upstream supplier to a lot of other packages, you probably need to be more worried about supply chain attacks, where someone inserts bad code into your package to try and get to someone else. Conversely, if you're working in some ecosystems, malicious package substitution might be more important. In our experience, things like the Python pip repository or NPM are magnets for not necessarily poorly maintained, but small-scale packages that people don't necessarily think about and aren't necessarily conducting audits of, being used to introduce all sorts of badness. Infrastructure takeover is much more important if you do have a lot more infrastructure. If you're running like something that can be self-hosted but also running a hosted version, someone taking that over is going to impact your project just as much as the code that you're shipping. Likewise, if you're doing open source work for a company, if your open source component is just one small part of a much larger, potentially not open project or organization, people might be trying to get into your project as a way to get to the rest of whatever they're actually after. There's a lot of scenarios you need to be prepared for, so you need to sit down, look at your project, look at your users, and think about what am I most worried about? Once you have that answer, it becomes a lot easier to do other things, including the fact you need to think like the bad guy here, and the first thing the bad guy is going to want to do is reconnaissance. Reconnaissance is a very easy term for InfoSec people to throw around because it basically just means looking for stuff. What you're looking for varies wildly, but you're looking for, as an attacker, you're looking for ways to get in, ways to get to what you want, what might be in there that you might want, all sorts of things. What defenses are in place? Is the target I'm attacking going to have a proficient security team who are looking for me, or is it just two guys on GitHub? There's a lot of things there. The problem is that basically all of those questions are answered by your excellent documentation, and all your very detailed bug trackers and automations and everything are telling the attackers answers to all the questions they need to know. They're going to sit down and say, oh, I wonder how this thing's been built. And if they're needing to answer that question for a proprietary closed source product, they're probably going to have to dig around to server headers and work out compilation artifacts and work out what server might be building this. Yours is a nice big YAML file in your repo that tells you exactly what GitHub run you're using. There's a lot of things you're giving away for free because that's how open source works that attackers are going to be able to use against you. That's not to say you shouldn't be providing those things. It's that you need to be aware that everything you know, they also know. And it's about a lot more than just your code. All those things there, developer tooling, paths, if you have contacts of, if you have a problem with X component, talk to so-and-so. Even small details like you'll see automations for issues of, this, if you open an issue and tag it with this component, it will automatically say, oh, the last person who committed to this was so-and-so. Now an attacker knows exactly who wrote that code and can look into that in more detail. There's a lot of issues that can come up because you're having to provide a lot of information to contributors. Which comes to the actual working in the open side of it. These are reasonably surface level ones, so I suspect a lot of you would intuitively understand that there's downsides to working in open source from a security point of view. You can't fix something without telling everyone exactly what you fixed. There's a reason that, for example, CVEs are frequently embargoed, and teams like ours will have to deal with patches and fixes and roll out new packages without ever revealing what it was that we fixed, because it's a nice big shopping list to attackers of, yes, this specific function in these specific versions has a buffer overflow that you trigger using this code. We don't really want to give that away while that's still out in the wild. So every commit you make is a nice convenient summary for anyone who wants to introduce badness or find problems in your project of any mistakes, vulnerabilities, anything like that. One of the other things that's easy to forget is that there is no quick enough. That the way the internet works is that if you have pushed a commit to GitHub, it's gone. It doesn't matter if you fixed it 30 seconds later, because GitHub's API picked it up, published it to anyone who uses their API, and it's out there. So to use the example that we see very frequently, API keys. There are plenty of people who will push their AWS API key, then like 30 seconds later, oh shit, fix that, and they'll even do a proper job with Git, remove all the old references to the commit, and it's great. But it doesn't matter, because GitHub's already published the original commit to their API feed, and it's probably on Twitter, because there are so many bots doing exactly that, of just scraping GitHub APIs, looking for keys and secrets. The other big one being the obvious one of there's no boundary. You can't rely on your firewall because you're on GitHub. There's no convenient, they won't be able to operate in this environment because this environment's only for this. It's the internet. There is no perimeter. It's just fucking Wild West out here. So the traditional wisdom you might find around security projects won't always apply to open source projects that are, particularly if you're running your infrastructure in the open as much as you are your code. One also is that I would specifically call out, did briefly mention earlier, is the outer loop things that it's easy to forget. Your public bug trackers are a one-stop shop of vulnerabilities. Not even just in the sense of finding a vulnerability and putting a bug in there, but that it's also an easy way for an attacker to see how often bugs are cropping up in a certain chunk of code. If there's a really crucial part of your code that no one's looked at in 3 years, that's probably where they're going to look at. And likewise, if there's, to borrow a talk from earlier, if you've got this great Kotlin app and then there's this weird nugget of Golang code in there that you're not really sure why it's there, they're probably going to look there because the odds are high that it might not have been reviewed as well, just based on the numbers. Likewise, while in corporate environments, it's very good to sit down and say, okay, this is restricted information, this is confidential information, this is public but not entirely, and this is everything. It's the internet, it's all public. There's no boundaries there. So even if your project has guidelines on what information can and can't be shared, that will only take you so far. And things like build pipelines. We'll cover build pipelines in a bit more detail, but it's very easy to forget that every push of code you run isn't just code being put in a Git repo. It's code that's being executed on someone else's server and doing things and reporting that output potentially to the entire internet. So the issues you can run into there are not always super obvious. There are a lot of ways to help that. Yeah, will Dependabot help? Absolutely. Dependabot is great. It'll tell you exactly when you've got vulnerable packages, tell you when you need to update your builds for out-of-date runners, all these sorts of things. Is it going to stop a determined attacker from finding a hole? Absolutely not. So make use of the things you can, make sure you're prepared for the stuff that you can't necessarily fix. Tuning out the white noise is very important. If you're running a large-scale project, you are going to get a lot of reports, particularly, and I want to specifically call out if you're running a bug bounty program. If you run a bug bounty program, this is 100 times worse. You will get reports for every bullshit reason you've ever heard. Sorry, excuse me. And it's going to happen that everyone will tell you, oh, do you know your GitHub's public? Like, we get those reports at Red Hat. We're aware. We noticed. You'll get reports of, oh, your bug tracker's free. I'm sure Mozilla's very sick of finding out that their Bugzilla is open to the public. It's kind of the idea. All of those things that we take for granted is just going to clog up your reporting paths. So it's not to say that these reports aren't valuable, it's that you need to have a way of tuning out the white noise so that you're finding out the stuff that is actually important. Because you really don't want to have to deal with every time someone sends you a thing saying, do you know your files are public? We know that. What we need to know is, did you know your Jira configs are public? Because you probably didn't want those to be public. Those sorts of things. So it's particularly important if you're working with bug bounties or where your project is part of a larger one, where there's going to be things that you don't want to be public and things you do want to be. You need to have a reliable way in your project of tuning out the terrible white noise from people whose reports you probably don't care about from the ones that are very important. That's particularly important. There's been a couple of references this week to disclosure policies. Have a disclosure policy so that people who are doing the proper way, doing their due diligence and have found a real security issue can follow a proper process. Added bonus, you can immediately close any issues that don't follow the proper process. And a lot of people are not going to be following that. And if they're not, the odds of their report being good are quite low. So that's an easy way to get a lot of the white noise out of the way at once. So now let's look at specifically infrastructure. Because a lot of open source work will be from people who are very, 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 very good at code. A lot of developers are not great sysadmins, as a lot of hard-learned lessons in the DevOps movement have found. The skill sets are not the same. But if you are running a project that has a lot of infrastructure around it, and the vast majority of open source projects have at least some, you need to be aware of that infrastructure. As I was saying earlier, there's everything from docs to demo sites, hosted versions. There's lots of scenarios where you might have more infrastructure than you were expecting to have. Even one of the smallest details that we'll come back to is domain names. So what should you be looking for? I know there's a lot of text, but it's not too bad. We'll cover keys and secrets a bit more in a second, but the important one is that there is so many keys and secrets and you need to have a way of managing them. Runaway bills can be a problem. If you have an AWS account attached to your project or you're using a paid GitHub plan that has unlimited build minutes, it's very easy for you to knock off on Friday, go down the pub, come back, and you owe them $150,000 because someone found a bug in your build pipeline. You don't want to have to deal with that because they're not going to follow your work schedule. The odds of the attacker being someone in your time zone working to business hours is pretty low. So you need to be aware that that's going to happen and be prepared with both well-documented processes for people who are in that time zone and automation for when no one's around. Service accounts can be an issue. There's a lot of issues, a lot of scenarios where developers are like, oh, just spin up the service account, it'll be fine. And that convenience is very good. It does come at a cost, and frequently that cost is measured with the number of zeros that comes after it. Because again, it's very easy if someone gets that service account that unless you are looking for it, you might not notice for ages what bills have been run up by that account. Pull requests is an important one that I think most people will understand but want to call out specifically. You can't trust the internet. Just generally, that's good life advice. And you really can't trust pull requests on GitHub. So things like GitHub actions that will fire off on every pull request, that's good, but you need to be, while GitHub will try and protect you, it can't protect you from everything. And you need to be aware that someone's probably going to try and put in a pull request that tries to print out all your environment variables, which probably includes all of your API keys. Things like that can be a problem. So you can implement things like not running build pipelines on first contributions, or only running them after someone okays a code review, things like that. There's a lot of scenarios you can do because you want to avoid as much as possible running someone else's code that you've never looked at, because they have looked at it and it's probably not good. Secrets. Secrets management is hard, apparently, because it's... Again, I cannot convey how many security incidents in open source projects come from people pushing credentials to GitHub. While I was doing this slide, their previous slide had those names on the bottom. That was just grabbed directly from the GitHub Events API. Wasn't even looking for it, found someone's AWS API key in the GitHub Events API. Because this happens. Now, a lot of the time, I should say, it's genuine, honest mistakes. Someone's trying to put in a placeholder and accidentally puts in the real one. Someone's putting in test data, and the test data actually, as it turns out, isn't test data and is real data. Putting in configuration examples in your documentation, saying, oh, here's where you set your AWS access key ID, and you set it just like this with my access key ID. Maybe don't. Things like that. It can happen very frequently, but just like with so many things in security, if you plan ahead and use proper secrets management, the odds of someone pushing their credentials direct to GitHub are a lot lower. Same vein of the sort of infrastructure one. If you're running your docs on your own server or you have a hosted one, don't open SSH to the internet, and certainly don't open SSH to the internet with root SSH enabled with a password of 123456, because it's going to get popped in like seconds. Yeah, the days of obscurity on the internet have long since passed, and if you leave weak infrastructure on the internet, it's not yours anymore. It's probably someone doing crypto mining, and it's saying something where someone dropping a crypto miner on your server is realistically the best case scenario, because it could be a lot worse. Secrets management is hard, and I will admit it actually is hard, but it's important to have a plan beforehand. There's no shortage of really good, even open source password managers out there. Even tools like GitHub and GitLab will provide you a lot of tools to try and make secrets management easier. Use them, even in small teams. Sign up for Bitwarden, use GitLab secrets, whatever you want to do. Ansible Vault is a nice, easy one where as long as you can share the password, you can dump as much as you want in there, and that file can be public because it's all encrypted to that. There's a lot of ways to do it. Use them. So that's planning mostly. Let's talk about actually dealing with incidents. There's two halves of that, which is finding out what happened, finding out, oh, hang on, that doesn't seem good, to, oh, no, this is real bad. There's a lot of scenarios here, and this is one where I'm going to have to be fairly high level, and you need to use the threat modeling we were talking about earlier to adapt to your project and the risks that you're trying to prevent. So if we look first at detection, you need to know there's a fire before you can put it out. And that only works, the classic scenario of you'll be able to smell the smoke. No, GitHub's got the smoke. You're at home and it's a great time. You need to be able to detect when something's happened to your project. Now, there's plenty of static analysis tooling to find problems in your code. There's ways to improve the security of your specific implementation. While it's very satisfying to have a README absolutely chock full of badges covering all the infinite variations of coverage tools, test suites, browser compatibility testing, that sort of thing, you need to be applying the same level of rigor to everything else about your project. Your GitHub Actions pipelines should be validated just as much as your actual code is. Every one of your configuration files you implement, even test ones and examples, should be running through linters so that you don't, for example, push your AWS API keys to GitHub. Are you spotting a recurring theme yet? There's just as many potential problems in your project infrastructure as there might be in your code. So while static analysis tools are very easy to implement, this stuff is a lot harder because you need to tailor it to your project. Sometimes it's also very easy to forget the smallest unit of risk, which is your account. Your project can have the greatest thing on the planet, but if your GitHub account has a terrible password and no two-factor, who cares? They're just going to log in as you and turn off all that good stuff. So your accounts are just as important as the project infrastructure. So use two-factor, use YubiKeys, use WebAuthn. There's a lot of ways you can do to actually improve the security of your account that reduces the likelihood of someone getting into the project through you. Added bonus, you can gloat over whichever of your fellow maintainers did get popped, that your account's fine, they were the problem. Get their shit together. One of the simplest things you can use for this is emails. That every platform will send you so many emails. So many emails. And it's very tempting to just have a rule that says, does it come from GitHub? Send it to archive, because I don't care. You don't want to do that. You want to actually sit down and set up, which of these alerts do I care about? Turn on the ones you do, turn off the ones you don't, and then actually read the emails, because they will tell you important things. Your dependabot summaries, you're probably just archiving because you get a lot of them. But finding out that there's a critical vulnerability in your project is a lot more important than finding out that left pad got updated again. There's a lot of very grey area in there, and you need to make sure that you can find the things that matter. So again, identify the key risks. As I was talking about earlier, that you need to match that to your project. We can't tell you what the answer is there. Use what the platform offers, whether that's emails, or a lot of platforms will have their own apps that can do push notifications, all those sorts of things. Whatever it is you're watching, you want to find out about it as fast as possible. Make it hard to undo. This one's important because it's not always of a huge importance to small projects with a small number of maintainers working on some code. But if your alerts can be bypassed by someone who's really trying to, they're not going to be much help. So again, if your GitHub account gets popped, they can just go in and turn off all those alerts that you've spent a lot of effort putting in. And you need to be prepared for that scenario. And it's where we'll come back later to logging, but things like alerting on if there's no alerts for a while, that can sometimes be a sign of problems of their own. So you need to watch what matters and across the entire team, particularly if you have other maintainers on the project. Remember too, it's very easy to shadow IT yourself, and immediate presumption is probably, I'm 3 maintainers, I'm not worried about shadow IT. It's very easy to shadow IT yourself, because you'll have set something up 2 years ago at night because you were worried about something and you just installed a few packages and look, now it runs. Did you document that? Because I'm guessing you probably didn't. I never do. And you've just shadow IT'd yourself. And those will come back to haunt you in very real terms. It's obviously much more of a risk in larger projects and organizations, but keep it in mind. And on that same vein, you want the safe process to be simple, because otherwise, whether it's you or another maintainer, you'll do it the unsafe way and you'll probably pay for that later. As an example, even a project with a handful of maintainers, who owns the domains for your project? You might have a .io or whatever else, very cool, catchy, short domain name. Whose account is that on? And is that account well protected? Because if it's not, someone's going to redirect your project's excellent, nice little Hugo-built docs site to malware. And now all of your users are getting served malware every time they open your docs site. That's probably not what you want, because it's not being properly managed. So create a Teams account with whatever registrar you use. Put the password in that secrets management that you definitely have set up. And you're already a long way to being able to avoid a lot of those scenarios. So, and likewise for maintainers, prepare for the scenario where a maintainer's out. If you're dealing with a problem with your domain name and the only maintainer who has the login to the registry is on holiday for the next 3 weeks, do you have a plan for that scenario? Because a lot of teams won't, and that can make things very difficult to deal with, particularly when you get to the incident response stage, i.e. you've got alerts that say, that's not good. What are you going to do now? Because a lot of teams, it can be very easy to be like, oh, I'm sure it won't happen. It might. And a lot of teams, including ours, where I work in a full-size team of incredibly capable security engineers, and we still can't catch everything, not in a million years. So we just get very good at cleaning up afterwards. You guys want to also be as good as you can at that process. We talked earlier about making sure you're getting alerts for important events. Here's why that's important, because that alert, the time it takes for you to get that alert, find out what it means, action it, and clean up after it, is crucial. The shorter that time window, the better, because speed is absolutely key. You need to know the moment something happens and be able to very quickly identify, is that a problem, and what's the problem? Because if you can't, your attacker's just free to do whatever they wanted to do in the first place. Attackers will have automation. To use the cloud as an example, if you don't think attackers are using Terraform to deploy stuff to pop to AWS accounts, have I got bad news for you? There's a lot of Terraform out there. You need to be not just automating things, but automating things better than the attackers will be. We all love over-engineering things. Over-engineering things is great. More things to over-engineer right here. Automate stuff. Log everything. Logging everything is absolutely crucial for reasons we'll get back to as well, because you need to be able to not just tell when something happened, but what happened, and the faster you can piece together exactly what they did and in what order, the faster you can undo that. So the more you can piece together and the quicker you get a holistic view of that, the faster you can undo damage from a potential attacker. Don't panic though. It's very easy to go, this is the first time I've had to deal with a security incident and someone's just changed our docs site to serve crypto miners to unsuspecting browsers. Oh God, what do I do? I'm just going to turn off the server. No. When the proverbial has hit the fan, you want to be turning off the fan, not tearing it out of the ceiling. And it's important to respond as quickly as you can, but without panicking. And that is part of why, again, the preparation phase is so important. If you have documentation or processes on what to do when X, you can just follow that thing. Follow it quickly, but just follow the guide. It reduces the chance of a mistake you make making things worse. That one also actually applies to vulnerabilities. How many times did it take to fix Log4j? Too many, because it's very easy to go, oh God, we need to fix something and introduce more bugs. Likewise, things like backporting. Backporting is hard because you can bring new bugs with you when you cherry pick future commits. There's a lot of problems there. Same applies to incident response, that you want to be trying to fix the problem without adding more. One of the big ones that is easy to forget for non-security people is to preserve what you can, because you won't be able to learn anything from an incident if you don't have any evidence of what happened. So to use the example of AWS, if someone's in your AWS account spinning up crypto miners in every region they have available, stop those instances, don't terminate them. Because if you terminate them, they're gone. If you've rotated the keys and you terminate the instances, you have no idea how they got in. It's probably going to happen again in 2 weeks because you won't have known what happened. If you stop those instances, you can get a snapshot of the disk, have a look. Sometimes it's very simple. Look at the disk, look at bash history, and oh look, I had a terrible root password on SSH. Sure. Sometimes it's quite difficult, and that's when you go find someone who's into security and has a lot of free time for some reason to help you with forensics, to find out what actually happened. Because you do want to know what happened. We'll get to that in the next one. The other one, which is a very niche case, but particularly important for really big projects. Plan for a hostile attacker. Yeah, to use the AWS example, if you've pushed your AWS API keys to GitHub and someone's in your AWS account, they're going to be really hard to get out of that account. And you might go in and go, I've got them now, and rotate that credential, you've got them. Did you rotate the 3 new keys they made in 3 different regions, one of which with a different name? Possibly not. You're now going to have to go in and undo each of those in order, because if you leave even one there too long, they use that key to generate more keys. Likewise, there's a lot of other weird junk you can do. Create a new instance with an attached IAM role. Now, unless you've also turned off that instance, they still have IAM access to your account. The scenario where you have an actual active hostile attacker is not something most projects are going to be dealing with, but if you think your project might, plan for it. And that's where that process is, writing down the process becomes very important, because things like order of operations is crucial. You need to be able to kick someone out and have them actually stay out. Which comes back to prevention. How do we learn from having made some terrible, terrible mistakes? You need to know how it happened. That's what's going with things like forensics, that you're not always going to need forensics. Sometimes it's going to be, that's my AWS key in our README. That's probably why. Sometimes it'll be really complicated. Like there's examples of, for example, generating passwords that happen to be the same as default passwords. That's very unlucky, but could happen. There's lots of things that you need to be able to know how it happened if you're going to stop it from happening again. The second, much more important part, how can you stop it from happening again? To use the example of if you've pushed your AWS keys to GitHub, how do you stop yourself doing that? Things like Git leaks is an excellent way to, and we'll cover that, of what do you need to know to stop it from happening again? And not necessarily the exact same one. You don't want to set up a rule, a pre-commit hook to say, don't push this string. You need to say, how do I stop pushing keys to GitHub? Maybe I could start using Ansible or Bitwarden or whatever else. Likewise for infrastructure. If I've got automatic build pipelines running, how do I stop not just this attacker, don't blacklist the user, but change how the build pipeline runs to maybe not expose so much valuable information? And the last one is limiting impact. No prevention is perfect. Again, I work in a massive team full of incredibly capable security people, and we can't stop it happening. Optus couldn't, Medibank couldn't, but that's its own problem. And you want to be able to limit how bad the impact is just as much as you want to be able to stop it happening. If you can't stop someone getting into your AWS account, it would be good if you had really restrictive cost caps on there. If you need to run GitHub Actions on every single commit from a third-party untrusted contributor, that's great. Maybe don't include all of your API keys with every build pipeline because you don't want them to have access to those things. No prevention is perfect, but limiting the impact will make it a lot easier on you and your team to stop the worst happening. The summary of that is prevention is still better. You want to catch things before they happen as much as possible, and even better is stop the actual root class of the problem. So to prevent pushing API keys to GitHub, things like Git leaks. If any of you has anyone heard of Git leaks? One, that's good. Git leaks is an excellent project that you can use to set up as pre-commit hooks, or you can run it on your own infrastructure. It's very flexible, and it will do things like scan your Git, and it will tell you when you push API keys. And you can set it up to find a lot of things. AWS keys, if your application has its own secret keys, seed values, anything like that, you can set those up to say, tell me before this happens. And there's a lot of different ways of using Git leaks, and it's not the only one. There's Git secrets, there's a few others. There's lots of ways of preventing things happening before they make it to the internet. Because remember from way back at the start, once it's on the internet, it's gone. You've lost it. It's all over. It's in someone else's hands. So catching things first is always much better. That also comes back to things like guidance and documentation. If you don't have developer guides and contribution guides, A, there's a bunch of docs people in this room who are coming for you, and this is a good example to get those. That if you have contribution guides and developer guides explaining how to set up the tooling properly and in a safe way, your developer's going to be much happier just being able to follow 3 steps in a Markdown document than just YOLOing it and hoping they set things up right. Added bonus, you can say, you're going to need this pre-commit hook to make sure you don't commit your own AWS keys. Make security part of the overall project process. As I was saying, you've probably already automated a lot of things. Sometimes it's something as simple as having a small amount of build pipeline running. Sometimes it's really complicated stuff, being able to deploy entire environments from GitHub or from GitLab, maybe running Jenkins for reasons I'm not going to ask you. There's a lot of scenarios where you might have a lot of automation running. Make those automations, secure the automations, and make sure that the processes that you're automating are secure processes. Because the only thing worse than an automated system being taken over is an automated system introducing something. If you have automated systems that just deploy code with 0 user interaction, the odds of it deploying a vulnerability are quite high. Now, there are middle grounds with that, where there can be too much automation. If you automate so that it just the entire release process is 0 human interaction, then if someone manages to sneak in a vulnerability, you have no chance to catch it. And that can be bad, and that's really a threat modeling thing of, is that something you're worried about? Maybe you have a completely automated process with 1 step in the middle that requires an actual human to say, that looks good. There's plenty of those available for GitHub or GitLab, things like that. Or if you're dealing with a larger team, have that as part of your process, that 1 person doesn't do the release, 1 person does most of the release, and a 2nd person checks. So you can over-automate, but automation's still better than not. Some solutions just aren't technical. I am a very technical person, but I still have to spend a lot of my days telling people to stop making bad decisions. Because at the end of the day, we're all fleshy humans at the end of the keyboard, and we're the ones making the mistakes. Sometimes we'll make the same mistake over and over again, and that's where you have to break out the technical solutions. Sometimes it's someone using the technical things exactly right, but differently to how you thought they would. And that's a case where you've got to stop and think, do I teach people how to do it the way I thought, or do I prepare my project for someone doing things differently to how I do? Some of the solutions aren't going to be technical, but I suspect a lot of people who are working on open source are looking for technical solutions wherever they can. The hammer and nail problem strikes again. Sometimes you're just going to have to deal with the fact that humans are the ones interacting with your project. So, what have we learned theoretically? Hopefully something. Security is a lot more than just your code. Preventing vulnerabilities from making it into your code is very important, but it's not the only thing. Planning ahead will 100% pay off. No matter how much you think, this is a bunch of wasted effort, it might be, and that is the best case scenario. The ideal world is you spent hours and hours crafting an immaculate security response process, and if you never have to use it, hell yes, win. Because take it from me, it's much worse when you do have to use it. Document everything, automate what you can. So where I go back to, there's limits to automation, but document everything as much as possible, not just so that you reduce the chance of mistakes, but so that you have a documented process for fixing mistakes. Use tooling and processes to reduce your risks. Things like build pipelines are very good for not introducing bugs. Use them to also not introduce vulnerabilities or introduce misconfigurations. You need to be able to use things like Git leaks or Git secrets to try and minimize how often you're leaking secrets or leaking information that turns out shouldn't be on the internet. There's a lot of situations there that you need to adapt to your project. And if anything, I should have put one at the top there. The number one is make sure it matches your project. There'll be no shortage of think pieces online about here's the steps you should take to secure your project. I'm doing one of those live right now. You need to match all of these guidance to what your project needs and the threats you're likely to be facing. Don't push your API keys to GitHub. I don't know how many times I have to say this, but apparently more. It happens. And to paraphrase an earlier comment, everyone's laughing going, I'm not going to do that. Yes, you are. One of you is going to. Don't open SSH to the internet. Common mistake, but worth pointing out that particularly in the era of public cloud, it's pretty easy to think of an instance in your Azure account as, oh yeah, that's just mine. If it's got an internet connection, it's on the internet. If it's got SSH, maybe don't enable root, to start with. And if you really need root, do not have a password and really do not have a bad password. Yes, that one you're thinking of, it's still bad. There's a lot of things you can do to just cover off the low-hanging fruit very, very quickly. That was very rapid fire, but that is roughly what we're going to deal with. It sounds like a lot of effort for not a lot of work, but again, take it from me, it's better to do the work and not have to use it than to have not done the work and be flailing around in the aftermath going, oh, the mistakes we have made. All right, thank you. I think we have a couple of minutes.
We'll
what was that?
We've got a couple of minutes for questions?
Yep, we've got 6 minutes. We got any questions? Yep. I'll bring the mic around, try to get everyone.
G'day, thank you for that. Excuse me. Feels like one of the ways that we need to improve our security is by practicing these kinds of responses. How can developers practice sort of being opponent? Right.
It's hard. To use the example that we would use in an actual incident response team, it's a very common tactic to actually have tabletop exercises where we'll sit down and run through, it's like any other tabletop scenario. Someone says, X has happened, what do you do? Okay, now Y has happened, what do you do? So on and so forth. And sometimes that's really complicated, setting up lab environments and testing out how it works and having to discover things as you go. But sometimes it's just sitting down and going, oh, I'd go do X. All right, you found Y. All right, I go do Z. That can be hard, particularly if no one involved in the project has a lot of security experience to be able to formulate those scenarios, but there are a lot of guides online for running those. They're particularly good if you're working in a team. If it's small-scale ones, one of the easiest ones I can probably recommend is just reading all the postmortems you get from incidents. That when companies have an incident, they'll publish, this is what happened, and they'll have big timelines of, we responded with X, Y, and Z. Or, correction, they should be publishing those things because it helps increase trust. But just as crucially, you can read those to find out what they did and get an idea. To use even some of the highest profile ones, the first thing that happens is someone leaked a key or someone had a bad password. And you can follow their timeline of, okay, they did this, how would I do that? They did that, okay, I'm never going to have that scenario, cool, who cares? What if it was X? So I think if you've got a larger team and you really want to get into it, tabletops are a really valuable exercise. For smaller teams, probably the easiest low commitment one I can recommend is just really going into some detail on some of those postmortems.
Hi, I have a very specific question. So a lot of us are working from home today, and I don't have a static IP address. Like my IP address gets dynamically allocated, as a lot of home setups do. So what would you do in terms of SSH? You said don't open it up to the internet.
So yeah, there's a couple of options there. There are some software solutions that I won't say get into if you don't already know them because they're a fairly sizable learning curve, but things like Cloudflare tunnels or other L2 mesh technology can be quite useful because you can install that agent, then close it down as far as that's concerned, and it's, without getting into too much complexity, it's essentially being VPN'd into that host. So that's one effect. The other one that's a very low-tech solution, but honestly not the worst, is just every time your IP changes, go change your AWS security group rules. I'm also on a dynamic IP, but my IP only changes probably at most every couple of weeks. I just go update those security group rules. The other one being that there is a little bit of obscurity. Don't put it on port 22. Don't open root, because the vast majority of probe attempts are on 22 to root. If you have a different administrative user, anyone who's looked at fail to ban logs will have seen that an administrative user with a name other than admin or root is probably not getting tried very often. So those are probably the easy ones, is see if there's another method of connectivity, just update your firewall rules when it changes, and a little bit of obscurity.
Probably got time for one more. Anyone else?
I think Fraser had one down here.
Oh.
How can we test the logging and monitoring and alerting?
Yeah, that one's tricky as well. One of the things I'll call out with this specifically, like being able to tell when something doesn't happen, is what we would refer to as canaries. If you're monitoring the logs for a system, make sure through whatever method, there's a lot of different ways of doing it, that you get a consistent log event. Sometimes it's a heartbeat or a canary or whatever that just sends a single log line that says alive once every 4 hours or whatever. Then you can alert that it's been more than 4 hours, we haven't got one. That's a problem. For being able to pick up actual badness, a lot of it is just having to trust your work. Some of it is if you have enough evidence, you can basically replay the attack. If you have enough evidence from an attack to say, okay, someone used an API key to issue these S3 calls and then did X, get one of your developers to do that. Just say, use your API key, do these steps, and hopefully you'll get a bunch of alerts show up. It's hard to just give the universal answer for how do we test logging and alerting, but the short version is probably make sure that you're actually getting the logs and have a way of finding out when you are or are not getting them, and as much as you can, try to do the thing that you're supposed to pick up and make sure you actually pick up on it. We do have another one back there if we have time.
Yeah, I think we go. Time for one more. Who was it? Sorry, Patricia.
something I notice a lot with cloud services and other SaaSes is that audit logs are usually behind some sort of enterprisey paywall. As an open source project that perhaps wants to make sure the audit logs don't have a nefarious actor or something in them, is there any movement or something in terms of getting audit logs for products, or like how do you do it when you not on a $10,000 a year enterprise plan?
Yeah, so that one's... there was actually a side in there that I cut for time on that basis, that there is a problem with logging, which is, where do you put the logs? That a lot of services will ask you a lot of money to run their own audit logging situations, but you also can't really just say, oh, just run your own elk stack and secure that and put all the logs there, it'll be fine. If you can, hell yeah, go for that. Run Elk, run Splunk, whatever you want to use, and alert on that stuff. But you don't always want to have to do that. In terms of getting audit logs out of the platform, there's not a lot we can do. There was a talk earlier in the week on OCSF, which is a event standard that, like, for example, AWS can output CloudTrails in a nice predictable schema that you can then process with any number of things. Like, you can set up with a log stack, but you can also just run GitHub Actions on the outputs, lots of other things you can do. But that only works in AWS. In Azure, they have their own stupid format with a lot of extra detail you don't need and a lot of details you may want but aren't there, all those sorts of things. The short version, which isn't a very helpful answer to your question, is there isn't a convenient answer, and you will have to sort of adapt how you get audit logs to what logs you're looking for and what you have available to you. If you can run your own elk stack and secure it, do it there. If you can't, you might have to jank it up a bit with CI jobs or schedule jobs, that sort of thing. Does that answer roughly?
Yeah, I was talking about the logging stack, like running the elk stack, whatever, is also public cloud's great for that project. For example, GitHub audit logs are only available in enterprise plans.
Okay, yeah, sorry. So GitHub, to use GitHub as an example, its audit logs are only available in enterprise plans. Yeah, there's no solution for that, unfortunately. That's just them being bad people, and those logs are only available if you pay them money. We can't really solve that. The best thing I can give is that if you're in a position where you can, like if you are doing open source at a company, make them pay for enterprise, because that's the value add, is whatever amount of money you have to pay GitHub to get those logs, it's worth it for the thing you can avoid from being able to process those logs. Because GitHub's not the only one, but unfortunately there's not really, I haven't seen any particularly effective solutions to be able to get logs from platforms that would otherwise charge you for them. Best I can say is you're kind of going to have to pay them sometimes, or change vendor if that's an option.
Thank you for that. We'll have to wrap it up there. Thank you very much, Alistair.
Thank you.